second, and go.
Hi, I'm Elijah Klett, and this is the direct and indirect radiation lab on how does the sun warm Earth. So first off, the sun heats up the Earth through radiation. Since there's no medium like the gas in the atmosphere and space, radiation is the primary way to heat travels in space. When the heat reaches Earth, it warms the molecules of the atmosphere, and they warm the molecules on us, and so on. Longitude is the dew point from west to east or east to west from the equator. Latitude is the point of or the distance from north to south from the equator. I am not originally from Temple. I'm from Seartown, Georgia, so the coordinates of my hometown would be, the latitude would be 34.0113 degrees north, and longitude would be 85.2566 degrees west. And that's my hometown, Seartown. But the coordinates of the current school that I'm in, current town I live in, which is Temple, Georgia, the latitude would be 33.7374 degrees north and a longitude of 85.0324 degrees west. I think the places that are further away from the equator get less sunlight and less heat due to the longitude and latitude, because if it's further south or north, it's further away from the equator, therefore that the sun doesn't hit that as direct as it hits the equator. Same goes for east and west, but it hits at different times. So that's basically how radiation works in the hot and cold, maybe then and there. But we're going to start off here with 90 degrees. We have our 12 inches, our protractor, and our flashlight, and it covers, there it goes. It covers about, oh god, I don't know how my lights is split.
No, you sure? Your flashlight. Sit your flashlight up there. It should sit on top of your protractor.
No, but I got it on point. So, it's about... Should we count the half squares and the quarter squares as holes, or...
They're not holes.
Just a big one? Just the whole ones? Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, and 78. So, at 90 degrees, from 12 inches up away from the paper, it covers 78 squares on the graph paper.
And how intense was the light? What was the intensity of the light? Was it like super bright? Was it faded?
It started to fade around probably about 75% away from the middle. It started to fade out, but it still covered the whole 78 squares. Now I gotta move this. To the center of the paper over here. Sorry, I'm thirsty. Alright. So, this is 60 degrees, which would be about... Oh, we're over here now. Oh. Sprite.
You can get another piece of tape if you need
it. It's okay. Okay, got this. 60 degrees is right here.
Alright, you don't want to go straight down. You want to angle for 60. You're going to angle outwards.
Outwards? Or should I angle
from
inwards?
the inside of the protractor from towards the inside, angle out at 60. Remember, like I showed you?
Like that.
Why is the flashlight seeming to dull? Let me see if I can set this
Oh, there it goes.
to where it'll
There it goes.
balance.
So it covers. And it kind of made like a diamond looking shape. In this area, right here.
Okay.
So at 60%, it covers 1, 2.
If you turn the
3,
flashlight
4,
off
5.
and lay it down, it wouldn't get dull. Will you just do the lab? You're on camera.
I know what I'm doing. Ah. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So, from 12 inches above the paper and at a 60-degree angle, we are up in the northwest part of the paper, and we have, did I say 26?
Just turn that flash off. We have glowing eyes.
Did I say 26?
32.
32. My bad, I'm sorry. I have really bad memory right now. 32 squares on the paper. Now, as you can tell, that is a huge difference from when it's facing at a 90 degree to a 60 degree. We are probably subtracting about a little over 44, probably about 45 or 46 squares less at a 60 degree than we had at a 90 degree.
And what's the intensity of the light?
Very intense for in the middle, like before. It's pretty intense all the way around it, except at the edges. So it's probably more about, it covers probably about 85% of intense light, and then it's probably about 15% dull. Excuse me, I gotta slide over something. Alright. Here is our 30%.
Now remember this one, you're gonna wanna.
This one don't cover much at all. It's like an actual little sun in a picture. In the 30%, if you can tell, actually, when you're moving from 90 to 60 to 30, it's moving the, what's it called? The duration of the light and the amount it covers is moving northwest of the paper. So, in the 30, we are covered by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares, which is 14 squares less than the 60, so it's not as much as a drastic decrease from the 90 to the 60, but it is still a drastic decrease in the amount of light that it covers.
What's the intensity?
It's intense all the way through the square, all the way across the squares. It has the same intensity all the way across the squares. We just ran out of paper. So, couldn't go any further with that one. We just ran out of paper.
Okay, now you have some questions that you have to answer there if you keep scrolling down.
Well, question 1 is, what angle had the most concentrated radiation? Ooh, excuse me. Which one had the most concentrated radiation would probably be our 90 degree, since most of the light was focused directly on here and it covered a much wider spread. When the 90 degree angle of radiation is a direct or indirect, it would be more of a direct light because it does focus more on the actual perimeters and everything. What angle receives the most concentrated and direct radiation? What can you infer about the temperatures there? Well, that would again be your 90-degree angle because it is. If we look at it like the Earth, that'd be your middle equator. Your 90 degree would be your middle equator because you have 0 and then 180 and then you got sides. So it's probably gonna be warmer in this area than it would be in your 30 or 60 degree. Sorry, I was pointing at the wrong ones.
Because
Dry mouth.
that's why you need water, not Coke.
Because of the fact that when it's at a 60 degree, it's focused more towards it's beaming more towards the upper northwest area, but still less than in the 30. But right here in the 90, it's just a straight concentrated light in one specific area. So there's no like extensive diameters or anything it has to go through. What in general can you infer about the energy per square meter at the equator? It's very hot. I'm not gonna lie. I wouldn't want to live there. I'd probably like to live around where we're at right now, in the northwest part of Georgia. It's cooler. But no, it is intensely hot in this area. That's where more of our deserts and everything are at. We have more deserts, more towards the southern part, but more towards the middle of the earth, which is the equator. That's where more of our for cactuses and lizards mostly like to live and stuff, because it's warmer there and they're cold-blooded creatures. What latitude receives the most indirect radiation? That would be your 30 degree. Your 30 degree receives the least amount of radiation because it is so far northwest. It is so further away from the equator, so therefore it doesn't get as much direct sunlight as the other two. At higher latitudes. What can you infer about the energy? Oh, we already done that one. No? At the poles.
Your north and south poles.
Yes, I know what it means.
Okay.
There's not much at all. It's very cold. It is freezing. That's why penguins live there. It's cold. I couldn't live there. It's too cold. Why was it important to keep the flashlight in the same distance in each time? Well, therefore you're not changing just like on Earth, the sun is the same distance from each and every point on Earth. So, therefore, if we move to the distance in it, we're basically making the sun closer to a certain point than it is from another point, which isn't right. The sun is an equal distance from each and every individual part of Earth. So if we kept in the same thing, we'd get kind of the same results, but in different areas and different temperature flux and everything. So that's why it's mainly important to keep it at the same distance from the paper. Yeah. How does the angle of the sun radiation affect the climate in certain latitudes? Well, if it's indirect, which, look at our 30 right here. If it's indirect, it's going to be colder up here in this area than it would be in our 90. But let's say we have 120, which is lower south than our 90. It's going to be cooler there than it is in our 90. Just because it's a higher degree doesn't mean that it's going to be warmer temperatures. It's more so what the distance away from the equator is. Because the further away from the equator you get, the colder it gets. That's why I like to live where I'm at. What are other factors can influence the climate? Well, weather, clouds, rain, oceans, stuff like that, because too much heat and radiation on the water can evaporate, which causes more storms, which can also cause lower temperatures. Influence the climate. Too much radiation and not enough water can cause a fire. Because there's so much heat on a certain area that has no moisture, it dries it up. And that's about it. Discuss on how the lab helps you understand the real world. It totally does. I don't really understand how this has any effect in the real world, but I do understand kind of more of how temperatures fluctuate around Earth and how the temperature changes due to the climate and the direction of the sun and radiation. So, I do understand that a lot more. And what new questions you have regarding these processes? Why would people like to live further away from the equator? That's my main question. It's too cold. I get ice fishing is fun, but I don't want to do it. Well, that's it. I'm Elijah. This was my, was this physical or Earth? This is Earth science. Earth systems. My bad, I'm sorry. This is my Earth systems, direct and indirect radiation project. I hope you enjoyed.